Hello everyone. Today we are going to do a very nice topic, which is distance, displacement, speed and velocity. I am also going to show with an experiment you can see over here, and it is a very suspicious topic. So let's start. Distance. The definition of distance is from A point to B point. The distance between that is called distance. The difference between that numbers are called distance. Then displacement. Displacement is the shortest distance from the internal to final position. Internal means the one A point and final means the B point. Then we have speed. Speed means we have given a number that 40 meters and 20 meters, but we don't know which direction it is. In velocity, we know that the 40 meters to the north and 20 meters to the south, something like that. So it has given a direction and distance both in velocity, and in speed we just have the distance. So let's start with the distance. What is the total distance you travel? So I have my house over here and I have my friend's house over here. Now it says total distance you traveled. So this part is 40 meters and this part is 30 meters. So I'll take this route to come at my friend's house. So we need to find the total distance, which is very easy. 40 plus 30 is equals to 70. So 70 meters. This is 70 meters. Then now let's go to the displacement. So in displacement is the shortest distance from internal to final position. So over here, this is a very long route which comes in 70 meters. But if I want to go with a short road, what can I use? This is a park, so I can go through the park. So let's use this path. So this will be the shortest distance. This will be a bit long. So over here, I use the same way from my house to my friend's house. Now, if I want to find the distance in this route, the displacement, so how can I find that? So as you know, it is making a right corner over here. This is making a triangle which has a right corner. So let's use the hypothesis over here. This is our hypothesis. Now, in this case, we have to find the root. So when we do the 30 square plus 40 square, we'll get 50 meters. So this is 50 meters long. And over here we had 70 meters. So, and now there is 50. So 70 is less than 50. 70 is more than 50. So this is the shortest route. Now let's see that if I have a curved path, like something like this, not the straight path but something like this. So how will I calculate the distance and the displacement in this case? So let's see. So the displacement will be the same because it doesn't matter that the road is curved or straight, but the distance is same because path is not changed. But how would I calculate the distance? The distance, I can take a rope and I have to put the rope through that road, and after all I have to measure that rope. So that then I'll get the distance of the road. So this is we have to use for a curved road. Now this is just for your keeping in mind that distance versus displacement. So distance is a scalar quantity and displacement is a vector quantity. Now scalar quantity has just a magnitude. Magnitude means that just has the distance like 40 meters, 20 meters, 30 meters and 70 meters. But vector quantity has magnitude and direction both. So magnitude means 20 meters but in south and 40 meters in north and some 70 meters in southwest. So something like that. That explains you that. So in our solution, in our experiment, it has displacement. When I took a compass, it says 50 meters northeast. Okay, so this is how we measure it whole. So when we just had 50 meters over here, it was just the distance. But now we have the displacement, which is 50 meters in northeast. Now, over here, let's go to next topic, which is speed. Rate of change of distance. Now, how the formula of finding the speed is distance divided by time. So our distance is 70 meters, which we go from here and go from reach our friend's house, which is 70 meters. And the time we took is already given, which is 1 minute 40 seconds. And we can't calculate it by minutes or hours. It has to be in seconds. So let's convert this into the second, which is 100 seconds. So now we got our distance and our 100 seconds. So now let's divide it by 70 meters divided by 100 seconds, which is equals to 0.7 meter per second. So this is called an SI unit. Now let's find the velocity. In velocity, the same kind of a same, but here we had distance and now we had displacement, but both are divided with the time. You can see over here we have distance divided by time, and over here with distance divided displacement divided by time. So in so our displacement is 50 meter, which we calculate like that. So that is 50 meters and 100 seconds, which time we took. Now we found that when we divide it, we got 0.5 meter per second. Now, total distance we travel. So, how could we get then for 140 meter? So, I went from here, which I took 100 seconds. But when I came back, I used my friend's car to go. So, I came in this kind of route, which just took me 40 seconds. So, when we total 100 plus 40, which is 140 seconds. So, in this case, our displacement is 0. Why? I'll tell you because this is our internal position, and this was our final position. But we came back to our final position, which is this. So the displacement will be 0 because this is our internal position and this is our final position too. So that's why the displacement is 0. Now speed. So in speed we have to find total distance by total time. We need to find total distance to total time. So over here we'll add total. So when we get that it's 140 meter by 140 seconds, because we need to total the all sides. So this was at 40 meters, 30 meters, 40 meters and 30 meters. When you total that, you will get 140. So 140 seconds, and we had 140 meters, which 1 meter per second. And we need to find average velocity, which is 0 meters. How? Because final position, internal position and final position are same in this case. So our displacement will be 0. And that's 140 seconds I took to come back to my friend's house. So this calculates 10 meter per second. So this is how the whole process works, and I hope you like my video. Thank you.